Hi, I'm Harshayu, and my project is the application of stylometry to identify misrepresentation in online financial analysis. So how many of you have used Quora or Wikipedia before? Over the past few decades, user-contributed information has skyrocketed. However, it has become easier for users to mask their identities online, and this can be dangerous in the financial realm. In fact, Seeking Alpha, one of the largest databases for financial analysis, has 80% of its articles written by only 20% of the users. Thus, we wanted to find a way to identify this misrepresentation in online financial analysis. So how do we analyze the articles? We use an algorithm called stylometry, which analyzes syntactic and linguistic features in an author's writing to attribute authorship for anonymous documents or in disputes. Furthermore, we customize stylometry by extracting features that are only relevant for financial articles, and in doing so, we can increase the accuracy of uncovering ghost authors. And the overall goal of the project was to expose Sybil identities, which are fake identities, and infiltrated databases to prevent financial scams. So what were the research goals? We wanted to accurately identify Sybils, and we wanted to find their role in society. How influential are they on a daily basis, and what is their effect on the average investor? We also wanted to see if there's any cross-domain involvement, for example, an author writing for both Wall Street Journal and Seeking Alpha. So how do we do this? The first step in the process was organizing the data. We crawled over 64,000 articles in 2014, and this consisted of over 2,000 unique authors. But all this data was collected in raw HTML format. So in order to analyze linguistic and syntactic features, we needed to convert this data into textual format. And once this was done using a library, we were able to apply the stylometry algorithm to it. So how does stylometry work? The first step is feature extraction. So we extracted linguistic characteristics such as vocabulary richness, word shape, the digits used, punctuation, syntactic pairs such as the letter combinations in words. And we also used article-based characteristics, which included things like bullets, italicized characters, bolded characters, graphs, images, charts, etc. And after we collected all the features, we needed to normalize them so that features could be compared among different authors. So after finding the features, we needed to find which features were actually important because we only guessed what we thought would be important. So we conducted something called information gain. And what information gain allows us to do is input our HTML features into a machine learning model called Weka, and it would output the most important features. And so how we did this was for example, we inputted 500 articles from one author and 500 random articles, and the machine learning model would learn which features are important in identifying that one author from the rest of the authors. And then after finding which features were important, we just needed to create a ground truth data set because, of course, we don't actually know which authors are real or fake online. So to do this, we generated 100 Sybil identities by splicing an article from one author and naming it as two different ones so that we know that it's written by the same one, but they have different names. And then finally, we ran the machine learning model, and then we analyzed the results. So first, we generated a training set for each author, and this just consisted of a percentage of the articles written by each author. And then following this, we inputted this into an SVM classifier, which is binary. So based on the features that are inputted, it knows, yes, it is this author, or no, it isn't. And then finally, we ran the data through a Weka model, which uses regression, classification, and feature selection to determine whether an article is written by an author or not based on the features provided. And then lastly, we analyzed the result using an ROC curve, which essentially plots the false positive and false negative values, and then outputs we can find the accuracy based on that. So this graph here shows the importance of the HTML features that we extracted. As you can see here, the number of bolded characters, italicized characters, number of bullets, and the number of characters in the bullets trended to be the most important. And we also found an interesting trend in the number of tables and the link references. They're extremely ineffective for some authors, but for some, like over here, they're extremely effective. So we found that they could be really decisive in identifying some authors. And then the number of images and average image size, they tended to be not incredibly important, but they still provided valuable information. And lastly, the color was pretty much useless and with this set of authors, so we pretty much discarded those features. And then this graph just shows the relative importance of all the features in a bar graph. As you can see, they're like pretty much evenly distributed. except color, which wasn't used. And then, so following the feature extraction, we needed to actually identify the Sybil pairs. So how do we do this? Our algorithm essentially compares each author, all sets of permutations, and it outputs a similarity between them using the SVM classifier. But how do we know which authors are Sybil or not? So we rank the probability from highest to lowest, but what is the minimum threshold for two authors to be considered a Sybil pair? To do this, we use the precision and recall graph. The precision uses the false positive rate, and the recall uses the false negative rate. And wherever these two graphs are the highest is where those values are the lowest. So we want to optimize them. So using the intersection point of these two graphs, we can identify the optimal threshold. And so as you can see in this graph, the optimal threshold is approximately 3 because the x-axis is a logarithmic scale, so it intersects at approximately 3. And this was using a data set of 200 Sybil and 200 legitimate authors. Then we repeated this for 200 Sybil and 400 legitimate authors, and it's approximately 3 again. So based on this, we can identify that the first 3 sets of comparisons are probably Sybil pairs. So what is the impact of this project on the financial world? Well, we can unmask ghost authors by finding which authors use shell names to publish articles. And in doing so, we can identify infiltrated databases, like which ones have more Sybil identities, which ones don't. And we can prevent pump and dump scams, which are essentially when an author uses various shell names to promote a stock using different articles. As you can see in this graph here, there's a 630% increase in a stock in only 7 days, so it does have a pretty big impact. And lastly, we can provide investors with authentic information by removing authors that are Sybil identities. And then what's next in the project? Well, we can increase the accuracy of this algorithm. We can find optimal features. We can do this by adding features, removing features, finding which features work best together. Or we can use different machine learning algorithms. As I mentioned earlier, we only used a binary classifier. Maybe we can use multi-class classifiers or use different ones that work in conjunction with one another. And it's not only improving the accuracy, we can develop a different performance matrix to evaluate the accuracy, because right now we're only using 1 out of like 1,000 different ways to measure accuracy. And then we can also apply this project to cross-domain scenarios. As I mentioned earlier, Wall Street Journal and Seeking Alpha, for example. And this project was only possible because of the following people. Dr. Ben Zhao, who was my mentor, Veena and Bolin, who worked on the project with me, Dr. Lena Kim for this opportunity, Marcela Arellano, my TA, the whole SandLab team, and my RMP peers, especially Subrao Garlapati, who woke me up during the entire program. Yeah, he was the best alarm clock, and that's it. Yeah.